Hello, this is the next video in a playlist that I'm calling Applied Multivariate Analysis using R software. And we're in chapter 10, part of this playlist that I'm calling Cluster Analysis. And let's jump to today's topic, which is hierarchical clustering with the complete linkage, also known as the farthest neighbor. Now, this is an agglomerative method starting with n clusters. And in the complete linkage methods, the distance between two clusters A and B is defined as the maximum distance between a point A and a point B. So mathematically, you describe it like this, that you look at every combination of the elements in A and the elements in B, and you find the two that have this maximum distance. And, it depends upon how you define distance. And then that's the distance between these two clusters, and then that's what you consider when combining, in the next step, using the minimum distance. So the distance is found between every pair of clusters. And these are the steps, and they're quite simple. Merge two clusters with the smallest distance. The number of clusters reduced by 1. After two clusters are merged, the procedure is repeated. The distance found between every pair of clusters. Merge the two clusters with smallest distance. Number of clusters is reduced by 1. And you just keep repeating until one cluster remains. And then I like to display the results in a plot known as a dendrogram. And let's illustrate that. Here we're going to read data from an FTP site. It's called Crime Data. And they look at murder, rape, robbery, assault, burglary, larceny, and theft between different cities. Okay, and so this is the print of the data. And so for each city, they have these results. Then we use the hierarchical clustering function in R called hclust, and we have to submit a distance matrix. So the distance of these variables in Y. Notice I removed the first column because it's not a continuous variable. And I use method complete, which is the complete linkage or the farthest neighbor method. And I store all the results in hc.complete. That's hierarchical clustering.complete method. Now, part of the output of hclust is what's called a merge matrix, and that tells you the order at which clusters were combined. A negative means an observation was merged, and a positive means a cluster was merged. So in step 1, observation 1 and observation 15 were merged because they had the smallest distance. Remember, we're using the complete linkage method. In the second step, the next two clusters merged were observation 9 and observation 10. And I'm going to skip to say step 4, observation 7, and the cluster created in step 1 are merged. Step 5, observation 4, and then the cluster created at step 2, right? It's a positive number, so that means it's a cluster, from a previous step. And then it just completes. So at step 12, the cluster created at step 9 is combined with the cluster created at step 11, and so forth. So now when we plot the data, we just say plot and then the HC complete, where we've stored all the information from hclust. And then the rectangle hclust is a way to graphically illustrate how many clusters you want. And I put in k equals 4. And you could put in any number you want there. And this is it. This is the dendrogram for the city crime data using the complete linkage. And then, of course, I told it to create 4 clusters from this data. And this is it. And if you looked at the previous video on this playlist, the single linkage method, it actually created a little bit different clusters. And so the clusters that are created are method dependent in this hierarchical clustering setting. Now let's look at what's called the average linkage. The average linkage, it's again an agglomerative method starting with n clusters, and in the average, misspelled average linkage method, The distance between two clusters A and B is defined as the average of all possible distances between the points in A and the points in B. So mathematically, you'd describe it like this. So it creates a distance between all possible points in A and B, and then takes the average. And then that's the distance that the algorithm considers when combining these two clusters. It may combine them next or not, but it creates a distance for all possible clusters, or all possible clusters. And the steps are actually just rinse and repeat from all previous methods in hierarchical clustering. The distance is found between every pair of clusters. You merge two clusters with the smallest distance. The number of clusters is reduced by 1. After two clusters are merged, the procedure is repeated. The distance found for every pair of clusters. Merge two clusters with the smallest distance. The number of clusters is reduced by 1. You just repeat until there's one cluster. And then we display the results, or I like to display the results in a plot known as a dendrogram. And so let's look at that. Again, we're using the city crime data from before. It's a 7-dimensional vector. And hclust is again the workhorse for hierarchical clustering in R, but we tell it we want method average. And then, of course, we don't want the first column because it's not continuous. We store everything in HC average. And then I like to look at this merge. It's not required, but especially if you're going to plot it, you can see all the information there. I just think that whoever created this way to describe how to merge these clusters was just genius. A negative means two observations. A positive means it's a previously defined cluster. So in step 15, the cluster created at step 13 is combined with the cluster created at step 14. When we plot the dendrogram for the city crime data using the average linkage method, we get this. And of course, the rect.hclust creates little rectangles around the dendrogram, and I said I want k equals 4, so that's why there's 4 clusters. Now, if you really just want to grab the clusters information, there's a better way to do it, and it's called a cut tree. And you can cut a tree at how many clusters you want, and then it just conveniently stores the information in a matrix that you can look at. And we'll cover that in a later video. But this is it. So this is the dendrogram for the average method using hierarchical clustering. Okay, so we're going to call her quits for this method. In the next video, we're going to look at the centroid method in hierarchical clustering. So I hope you enjoyed this. I sure did. Please like the video and subscribe so you don't miss the next one. Thanks. Bye.